Betelgeuse has captivated the scientific community, especially astronomers, with its unpredictable behavior and mysterious properties. Located in the constellation of Orion, this massive red supergiant has experienced extreme fluctuations in brightness in recent years, leading to speculation that it is nearing its end as a supernova. Despite this speculation, the star continues to puzzle experts, with new theories emerging about its rotational speed, its companion star, and the strange events that seem to change our understanding of the star. Officially known as Betelgeuse, but often referred to in popular culture as Betelgeuse, the star lies to the right shoulder of Orion, one of the most recognizable constellations in the night sky. The star has long attracted the attention of professional astronomers and amateur stargazers, but it gained particular attention when its brightness began to fluctuate wildly, sparking widespread speculation about the possibility that the star could be on the verge of a supernova explosion. As a red supergiant, Betelgeuse is in the final stages of its stellar life cycle, so such a catastrophic event seems not only possible but inevitable. But recent discoveries suggest that this fiery demise may be much further away than many initially thought. At first glance, Betelgeuse looks like a typical red supergiant, a class of stars known for their massive size and relatively low surface temperatures. In terms of sheer size, Betelgeuse dwarfs our own Sunday. At nearly 1.4 million kilometers in diameter, our Sun could fit about 1.3 million Earths, but Betelgeuse is a different beast altogether. Its diameter is about 800 times that of the Sun, and its length is over 1.2 billion kilometers, which is enough to engulf the entire inner solar system. To put this size difference in perspective, if Betelgeuse were located at the center of our solar system, it would extend beyond the orbit of Jupiter. Luminosity for its size. Betelgeuse shines about 10,000 times brighter than the Sun, which is a testament to its majesty and power. Despite its immense brightness and size, the star surprised astronomers by dimming dramatically in December 2019, losing much of its brightness in just a few weeks. This was no small change. Betelgeuse, normally one of the brightest stars in the sky, dimmed to the point where it fell to 21st place on the brightness scale. What made this particularly interesting was the speed at which it happened. Periodic fluctuations in brightness are normal for red supergiants like Betelgeuse, but this dimming occurred much faster and more pronounced than anything previously observed. To understand the significance of this event, it's important to consider how astronomers measure a star's brightness. They use a scale called magnitude, where a smaller value indicates a brighter star. Betelgeuse typically shines at magnitude 0.3 to 0.4, making it one of the brightest stars visible from Earth. However, in late 2019, its magnitude dropped to 1.1, causing the night sky to become significantly darker. This sparked a flurry of activity among astronomers trying to explain this sudden dimming. One of the earliest theories was that Betelgeuse would go supernova. Given its status as a red supergiant nearing the end of its lifespan, this was far-fetched. In fact, many have speculated that such a sudden change in brightness could be a precursor to the star's explosive death. When red supergiants run out of nuclear fuel, they often collapse under their own gravity, creating a powerful explosion that can dwarf entire galaxies for a short period of time. In the case of Betelgeuse, the supernova would increase in brightness so rapidly that some experts predict it could become as bright as the full moon and even be visible during the day. However, further investigation has shown that the blackout was likely caused by something much less dramatic, if not quite as exciting. After analyzing follow-up observations, the researchers discovered that the blackout was the result of a powerful plasma discharge from Betelgeuse's surface. The explosion ejected a huge cloud of dust into space, temporarily dimming the light and making it appear darker from our perspective as it drifted between Earth and the star. This discovery represents a major change in how astronomers understand the life cycle of a red supergiant, highlighting the complex interactions between stellar matter and the space surrounding an aging star. Plasma eruptions are not uncommon for red supergiants, especially those in the later stages of their life cycles. These stars lose enormous amounts of stellar matter, which is carried to their surface by convection within their interior. In the case of Betelgeuse, these flows created the conditions for a particularly intense plasma eruption. The material ejected during this event eventually cooled and condensed into a dust cloud that covered much of the star from our perspective on Earth, leading to the dramatic dimming observed in late 2019. In the context of astronomical research, Betelgeuse's behavior is of great interest not only because it provides a glimpse into the final stages of stellar evolution, but also because it challenges many of the existing models used to explain stellar behavior. One of the most puzzling aspects of Betelgeuse's recent activity is its rotational speed. Red supergiants tend to rotate slowly because they lose angular momentum over time. However, observations with the ALMA radio telescope have shown that Betelgeuse is rotating much faster than expected for its type of star. In fact, Betelgeuse's rotation speed is estimated to be around 5 kilometers per second, which is 50 times faster than the rotation speed of a spectral star. This unexpected discovery led to the development of a new theory, that Betelgeuse may have consumed its companion star during its expansion into a supergiant about 100,000 years ago. This hypothetical cannibalism would transfer the angular momentum of the companion star to Betelgeuse, accelerating its rotation. The theory is supported by computer models suggesting that the angular momentum of the swallowed star could explain Betelgeuse's surprisingly fast rotation. In addition, images from the Herschel Space Telescope provided additional evidence, showing two regions of stellar material ejected from one side of the star. These shell-like structures are located at distances corresponding to the cannibalism events, lending weight to the hypothesis. However, there are other possible explanations for Betelgeuse's rapid rotation. Some astronomers have suggested that the movement of large convective bubbles on the star's surface could create the illusion of a faster rotation. Recent analyses of ALMA data, combined with astrophysical models, suggest that this illusion is a plausible explanation. In fact, some researchers believe there is a 90% chance that the apparent rapid rotation is the result of a misinterpretation of the low resolution of the ALMA images. Despite these uncertainties, the possibility that Betelgeuse once swallowed a companion star remains an intriguing idea, and astronomers continue to explore this hypothesis as more data is collected. In addition to the mystery of Betelgeuse's rotation, there may be a smaller companion star that further complicates its already mysterious nature. Astronomers have long noticed that Betelgeuse's brightness pulsates with a period of roughly 400 days. But the star also exhibits longer-term fluctuations, with a secondary cycle lasting about 2,170 days, or nearly 6 years. The cause of these long-term oscillations has been unclear for years, but recent research has shed new light on the phenomenon. Jared Goldberg and his colleagues at the Flatiron Institute in New York City re-examined Betelgeuse observations and found some anomalies. In particular, they found that the 6-year period of Betelgeuse's light curve did not coincide with the 400-day pulsation, suggesting that the two phenomena have different origins. After ruling out other potential causes, such as magnetic effects or convection, the researchers concluded that the most likely explanation for the long-term oscillations is the presence of a companion star orbiting Betelgeuse. This companion star is much smaller than Betelgeuse, but it still exerts a gravitational influence on the larger companion, causing changes in the dust and gas distribution around the star. As the companion star orbits Betelgeuse, it may occasionally displace dust clouds that obscure the red supergiant, contributing to the observed brightness changes. Furthermore, the orbital motion of the companion star causes periodic changes in Betelgeuse's light curve, explaining the 6-year cycle. Despite this strong evidence, the companion has not yet been directly detected. The team's calculations suggest that the companion is most likely a low-mass star, with a mass of only about 1.7 times that of the Sun. By comparison, Betelgeuse is nearly 20 times that of the Sun. The companion is difficult to detect because it is so close to Betelgeuse, which has a radius of only 2.4 times that of Betelgeuse, making it stand out against the overwhelming brightness of the red supergiant. The combined luminosity of the two stars makes it difficult to separate the companion's contribution to the light curve. However, researchers hope that with modern telescopes and more sophisticated observation techniques, they will eventually be able to detect the satellite directly and gather more data about its properties. For now, the question of whether Betelgeuse has a companion star remains one of the many mysteries surrounding this mysterious red supergiant. The scientific community is eager to investigate this mystery further, and has applied for observations from the world's largest and most powerful telescopes to help solve it. If a companion star is found, it could provide important insights into the evolution of massive stars like Betelgeuse, especially those that are dual systems. Regardless of the results of future observations, Betelgeuse's unusual behavior and mysterious properties will remain a focus of astronomical research for years to come.